Okay, let's talk about section 3.8. Let me summarize like what I learned in section 3.7. We are talking about vibration model, and in section 3.7, we derive the differential equation for vibration model, and we took care of the the uh, without damping, which is undamped free vibration model. We talked about with damping as well, okay, which is like a damped free vibration model, okay. But so far, I mean, like in section 3.7, there was no external force, which means there is no right-hand side. Your right-hand side was 0, okay. But in section 3.8, we will add and we will make a little bit more complicated case, okay. So look at that. This is mathematical model for the vibration motion. So M is the mass, and B is the damping coefficient, and K is the spring constant, okay? All those M, B, Ks are like positive constant, okay? And now we're gonna add the right-hand side, which is external force, okay? But like for this study, that we're gonna restrict the your external force term as the periodic external force. Okay, so like for that purpose, we're gonna keep your capital Ft as F0 cosine gamma t. As you know, like this one, F0 is the like amplitude of your external force, and gamma is the frequency. Okay, and we assume both of F0 and gamma is positive. Okay, then we can have this guy. Okay, my double prime plus by prime plus ky is equal to F0 cosine gamma t. Well, in the previous chapter, we use u instead of y, but it doesn't matter. Okay, okay, here we go. Then, okay, look at that. If you do not have your right-hand side, which means homogeneous equation, then we know we can solve the differential equation, second order linear differential equation with a characteristic equation. That's what it did in section 3.7. But what about this guy? This one, how can I? Okay, like for this case, as you remember, like in section 3.1 through 5, there are two parts of the solution. Okay, first one is homogeneous. I mean, like the solution for the corresponding homogeneous equation, and we have to find the particular solution. I'm talking about this capital Y. Okay, so here we go. So let's start from corresponding homogeneous equation. We are familiar with this one. This can be found by the characteristic equation, but we're gonna say it is the transition solution. Okay, let me try to explain why. Okay, basically, when you solve the characteristic characteristic equation for corresponding homogeneous equation, it is maybe, let me write like a different color. It will be m r squared plus br plus k r equals 0. Okay, then definitely we're going to use the quadratic formula. Then your r is equal to minus b plus and minus square root of b squared minus 4 mk over 2m, right? So look at that. Like I explained this one before. This value r is always negative because mr, mbr, or the coefficient mbrs are positive. Okay, then look at that. If you do not have minus 4 mk, it is just simply square root of b squared. Then your numerator will be equal to 0, right? But keep that in mind, since m and k's are positive, and this negative is you're gonna subtract some positive number, which means under the square root is less than b squared. In other words, your square root part is less than b, okay? And minus b plus like less than less number less than b or subtract, and both of them is negative. That's why we can say your r, which is solution of this characteristic equation, is negative. Okay, so in other words, this r will be the exponential function form, right? And I mean your solution will be e to the rt form. Then okay, again, since this r is negative, which means that your exponent part of exponential function is negative, then as long as like t is increasing, like this part goes to 0. Okay, so that's why, like finally, what I want to say is your homogeneous, I mean corresponding homogeneous solution, solution of like corresponding homogeneous equation part will be goes to 0. That's why we can say it is transient solution. Okay, which means that it will be gone. Okay, so finally, whenever your t is increasing, the part you will have like from the solution is like particular solution part. Does make sense? Okay, and as we talked about like this particular solution in chapter 3.5, like since your right hand side is cosine function, your particular solution must be the combination of like sine and cosine function form, which is we can write a sine gamma t plus b cosine gamma t, or we like normally use like cosine first, but like it doesn't matter. Okay, so we can say that is the like a steady state solution, which means like when t is increasing, this part will be survived. Okay, so like let's talk about the detail of this. Okay, do you remember? Okay, here we go. Like, do you remember like what we did like in undetermined coefficient method? Okay, like whenever you set up your particular solution, we find y prime and y double prime, and we plug it back into the differential equation, then you can get this a and b. Okay, so well, like, and if I just like skip like this way, then you are not gonna understand. You can understand it. Okay, so let me talk about the detail of like this equation number 8. Okay, here we go. Let's talk about this in the next page. So okay, we find the form of the particular solution is like this way, right? A equal to a, well, I mean y is equal to a sine gamma t plus b cosine gamma t. As I explained, we're gonna find y prime and y double prime, and we're gonna plug it back into the differential equation. Okay, y prime is equal to gamma a cosine gamma t and minus gamma b sine gamma t. Okay, what about y double prime? Okay, and again minus gamma square, because like all these are coefficient. Okay, and a sine gamma t minus gamma square b cosine gamma t. Okay, once you have like y prime and y double prime, we're gonna plug it back into the differential equation, which means my m y double prime plus b y prime plus k y is equal to f0 cosine gamma t will be like this form. It will be a little bit complicated, but you can do okay. M times y double prime, which is minus gamma square a sine gamma t minus gamma square b cosine gamma t plus b gamma a cosine gamma t minus gamma b sine gamma t. We just did like first one, okay? And then, okay, let me make a bigger parenthesis, and plus b times y prime, which is gamma a cosine gamma t minus gamma b sine gamma t, okay? And third part, I hope I do not make any mistake for this one because this is online. I cannot communicate with you guys, which means even you find my mistake, but there's no way to fix it because I'm just recording my work right now. Sorry about that. Is equal to your right hand side, which is f0 times cosine gamma t. Okay. Well, like like I believe already, like a couple of you just like disappointed and like depressed because like this is too complicated. Okay, but keep that in mind. As I told you, this course has two parts. Okay, like theory part and the practice part. Okay, so most exam is based on practice. Okay, not the theory. Okay, I'm not gonna ask you to derive like hold this thing by yourself. Okay, but like try to understand what I'm doing. Okay, that's enough. Okay, so let me keep doing. Okay, so keep that in mind. The purpose of this whole crazy process is to finding coefficient A and B in terms of like F0 and gamma. Okay, so let me try to simplify like these equations. Okay, so like I'm gonna get all the sine part on your left hand side and cosine part on your left hand side, and I'm gonna compare with your right hand side. Okay, here we go. Let me write all the sine part first. Okay, then with sine gamma t, and we need big parentheses. And from first one, it is minus m gamma square a and minus m gamma square. Oh, no, this is not the one. Okay, I'm talking about sine part on until this one. Okay, it might be better to use the red one. Okay, sine gamma t, and what is it? Minus m gamma square a and minus b gamma b and give me 1 second. Something wrong, right? There we go. I got it. So this part is just like duplicated, right? I did like 2 times, okay? So I really don't want to stop this video because like I spent a lot of time already. Here we go. So let me do it again, okay? But forgive me. Sine gamma t minus m gamma square a and minus b gamma b plus, okay, that is what I wanted, okay? And then the second part, I'm talking about cosine function part. Okay, let me get everything, okay? And this will be by cosine gamma t and we have minus m gamma square b plus b gamma a plus kb, then that is equal to f0 cosine gamma t. Okay, look at this one. As I told you before, that what we're going to do is we're going to just try to compare your left hand side and right hand side. Okay, look at that. On your right hand side, there's no sine function, which means your like left hand side must like this part must be equal to 0. Okay, and then what about this guy? This part must be equal to f0. Is okay? Then we can set up the system. Here we go. Then we're going to have like beautiful system. Okay, first one, minus m gamma square a minus b gamma b plus ka must be equal to 0. And the second part, minus m gamma square b plus b gamma a plus kb must be equal to f0. Okay, now we are here. Okay, again, the purpose of this whole crazy process is to finding coefficient A and B in terms of gamma n or the other constant which is given. Okay, so now what I'm going to do is like let me simplify a little bit. Okay, and we're going to gather all the A's from the first equation, so which means k minus m gamma square A minus b gamma b equals 0 from first one. The second one, just like simply b gamma A, and what about b part? K minus m gamma square b must be equal to f0. Okay, there's still, as you know, like there's two ways to solve this problem. Like first one is the like elimination things. Okay, and or we can do substitution, right? For this case, let me show you how we can do elimination. Okay, so like let me try to cancel out b. Okay, to do so, like I'm going to multiply k minus m gamma square to the first one, and I'm going to multiply b gamma for the second equation. Okay, then like you have this one. The first one will be k minus m gamma square a minus b gamma and k minus, it might be better to write this on the bottom. Okay, let me do it again. What I want to do is I'm going to multiply k minus m gamma square for the first one. The second one, we're going to multiply b gamma. Okay, then you're going to have like this form: k minus m gamma square a minus b gamma and k minus m gamma square b equals 0. The second one will be b square gamma square a plus b gamma times k minus m gamma square b equal to b gamma f0. Now look at that. This guy and this guy. They equal to each other, right? Then we can simply add up, then they will be gone. Okay? Then this will be like this form. K minus m gamma square plus b square gamma square of a must be equal to b gamma and f0. Okay, then now when you divide by the coefficient of a, your a is equal to b gamma f0 over k minus m gamma square plus b square gamma square, right? And when you plug it back into the like first or second equation of the system, doesn't matter, okay? Then you're gonna get like a b as like this way. B is f0 and k minus m gamma square over k minus m gamma square plus b square gamma square. Okay, that's a really crazy process. Okay, but again, okay, don't be depressed. Okay, as I told you, I'm not gonna ask you to derive like whole this crazy process. Okay, but like try to understand what you're doing. Okay, so now we have like a and b. Okay, let me come back to the problem. Okay, let me come back to the model. Okay, and we just found a and b. What is a and b again? Okay, let me come back. I'm talking about this particular solution. Okay, I'm talking about the coefficient of like this particular solution. Okay, but okay, let me talk about a little bit more about this. So do you remember whenever you have like this like a combination form of sine and cosine, we would love to write as one single cosine function to talk about amplitude and frequency and phase. That's what it did like in the previous chapter, right? So like we're going to do the same thing. Okay, here we go. From that one, and I'm talking about this guy. Okay, your a cosine sine gamma t plus b cosine gamma t form can be written by R cosine gamma t minus delta, right? The where your R is equal to square root of b squared plus b squared, and your tangent delta is b over a, right? Okay, that's what it learned like in section 3.7. Okay, oh, I say that right already, but you know, and anyway, with this calculation, you can find y. Okay, are you okay so far? That's crazy, right? I know, but like from this one, okay. Look at that. Basically, this is periodic, right? Like this one has the same frequency gamma with the like external force term, right? I'm talking about this gamma, okay? But the amplitude is different, right? Like in the like external force form, like your external force was F0 times cosine, right? Cosine gamma t, right? Which means your amplitude was F of zero, F0, right? But when you look at this one, this particular solution has like different like amplitude with a like external term, right? But it's really makes sense, right? Because like with external force, then your vibration motion is changing, but like cannot be exactly the same with your external force, right? That's why it is different. Okay, so like what we're gonna do is we're gonna just try to compare your external force amount and your particular source. Okay, just compare this one with your external force. Okay, what is difference? That's exactly your denominator part. Okay, I'm talking about this guy. Okay, which is the denominator of your particular solution, right? We're gonna say that is the frequency gain or gain factor. Okay, since the video is too long, let me stop here. Then we're gonna talk about second part. Okay, thank you.